Now, why do we need the optical fiber communication? We have different type of communication system. We have analog communication system, we have digital communication system, we have satellite system, we have wireless system. So lots of type of communication systems are there, but still we have optical communication system, right? So what are the advantages? So first of all, one of the most important advantage is the enormous potential bandwidth. You can say one fiber can carry uh, all the uh, all the telephonic data of a small town, right? It has got huge amount of bandwidth because it is using tens of terahertz of frequency, right? So it can have huge amount of bandwidth. Next is the small size and weight. Actually, optical fiber, when you will discuss those things, uh, the diameter of the optical fiber is very small, of the order of micrometer or tens of or hundreds of micrometer. Okay, so its size is very small. Also, the transmitter and receiver, they are also very small, very tiny, and their weight is also very small. Next is the electrical isolation. That is also one of the major advantage. Electrical isolation means when we have if we have any kind of electrical disturbances, that disturbance will never interfere with the optical fiber system. So that is a big advantage of this particular kind of system. Immunity to interference and crosstalk, we will discuss this thing later on. Signal security. See, in air medium, when we try to transmit the signal, if we have a receiver, hmm, which is unauthorized receiver, can detect the signal very easily, because we never have such restriction, so that the unauthorized receiver will not uh, able to detect the signal. We have some security aspects, that is a different issue, but as far reception is concerned, we can receive it, right? But as far optical fiber is concerned, you never have the access to the signal which is flowing through the fiber core. Get it? Because that particular signal will not be radiated in the outside world. All the signals will be will be residing inside the core of the fiber. So if we really want to get the signal, we have to open the fiber. Until we open the fiber, we will not be able to detect the signal or get the signal, or unauthorized reception is almost nil for optical communication system. So in that aspect, it is highly secured system. Low transmission loss. Nowadays we have very good quality fibers, and the transmission attenuation per kilometer is of the order of even less than 1 dB, 1 dB per kilometer. So the transmission is really low loss transmission. So have we can have a um, transmitter and receiver which is separated by hundreds of kilometer distance. So wave can travel, or we have a long haul communication in in optical domain. Okay, ruggedness and flexibility. You can easily modify the system even without changing the laid fiber. System reliability and ease of maintenance. Ease of maintenance we will discuss later on. And there is a unique feature of optical fiber. Most of the time, if we have some trouble in the system, what we have to do, we have to go to that particular location and we have to search for it. Okay, for long haul communication system, we have to search where is the problem, right? But in optical fiber communication, we have the system that will tell us that what is the exact position of the problem and what is the kind of problem the fiber is facing. Okay, like whether there is a fiber cut, whether there is some bending in the fiber or something like that, it is very easier to detect that particular problem and the distance of that particular problem, distance of occurrence of that particular problem, instead of going and search for it. So we can have a system located either in the transmitter side or at the receiver side, and that particular system will tell us the location of the problem. Okay, so it is, the maintenance is very easy for optical fiber communication system and potential low cost. That means initially the fiber laying and all the other things may appear to be costly, but in long run you can say that, well, it is low cost. Okay, because years within few years the installation charges or installation expenditures will be, you will get the enough amount of money, so the installation expenses will be recovered. Okay, so it is potentially low cost, and as the maintenance is easier, so in the long run it is very much useful. So first of all, uh, to understand the optical fiber communication system, you must understand the basics of optical fiber, right? So basically optical fiber implies it is a glass fiber, though different type of fibers are now there. Plastic fibers are there, but for the sake of simplicity, we will, most of the time we will assume the fiber is a glass fiber. Okay, and fiber is basically a cylindrical shaped glass fiber uh, with two different refractive indices. At the center part, we have a region where the refractive index is N1, and that particular region is called the core region. And outside this core region, we have another cylindrical area with refractive index N2, and this particular region is called the cladding region. Okay, and this core region, this one, is actually little bit, the value is little bit higher than this cladding region. Okay, so that uh, the internal reflection would take place, and the light energy will reside inside the core. Okay, to understand the propagation of electromagnetic wave or the light wave through the optical fiber, first we must understand the basic ray theory of transmission, that is the total internal reflection. So let us recall the famous Snell's law. If this is the incident ray and uh, this is the high index region and this is the low index region, and this is the surface between these two regions, one is the glass, another is say air. So incident ray is in, with the incident angle of phi 1 is falling on this surface, and then a portion of it is refracted as a exit ray with the angle of phi 2, and another portion is reflected in the same medium with the same angle of phi 1. Okay, so accordingly we have sine phi 1 by sine phi 2 equal to n2 by n1. This is a famous law. Now if we change this phi 1, okay, if we increase this phi 1, what will happen? Obviously this exit ray will be more close to the uh, common surface. That means phi 2 will also increase, right, according to this law. So when phi 2, this one, phi 2 becomes 90 degree, at a certain angle of certain incident angle phi c, the transmitted ray is just going, it will be the parallel to the surface. That is, the angle of refraction becomes 90 degree. Then the corresponding incident angle is called the critical angle. So sine phi c is equal to n2 by n1, putting phi 2 equal to 90 degree. Now, if the angle becomes more than phi c, what will happen? So obviously, the electromagnetic wave, the light wave, will never go to the n2 region. That is, it will never go to the second region. Total light will be reflected back into the same medium, okay, when the incident angle is greater than phi c, okay. And this particular phenomena is called the total internal reflection. And beauty of this particular type of reflection is that there is no loss of power. That means the total power is reflected, so there is no chance that some power will be transmitted in the other medium. Under total internal reflection, all the power will come back to the same medium, okay, provided the angle of incident is greater than the critical angle. So this is the basic of the propagation of light wave through the optical fiber.